Here I would like to talk about surface tension. Surface tension is one more property of liquids. Earlier we discussed the property of viscosity, and here I will be discussing surface tension. There are a number of approaches we can have for understanding surface tension. What I have done is I have broken up that into two parts. In the first part, we will be having a look at the microscopic view of surface tension, and in a future video I will look at surface tension at the microscopic level. So when we look at the microscopic level, we will look at what's happening to the molecules inside the liquid, whereas here we'll just have an overall look at what surface tension is and what are the effects of surface tension, so that we get a background about surface tension, and then it would be easier for us to understand what is happening at the microscopic level. What I've done is I'm first talking about effects of surface tension. I'm going to talk about some real life examples of surface tension, and then probably look at the quantitative aspect of surface tension. So what I'm starting off with is giving you examples of some effects in real life about surface tension. So let us look at some of the effects. The first effect that we have of surface tension is the tendency to act like a stretched membrane. So if I take, say for example, a container in which I have some particular liquid, let us say we have water over here. Because of surface tension, this surface of the liquid, this particular part, acts like a stretched membrane. So that is the first effect that we have of surface tension. This surface acts like as if it has been pulled in this particular direction, into opposite directions, and therefore it feels as if it has been stretched. Something like this. Say for example, I have a rubber sheet over here, and right now it's in its normal position. Now if I assume this to be the surface of the liquid right now appears to be in normal position, but because of surface tension it gets stretched in this particular direction, and this is what happens to the surface of the liquid. Of course it is not visible to the naked eye, but the surface of the liquid acts as if it is being stretched in the two lateral directions. So there's a force acting, one in this direction, the other in this direction. That is how the surface of a liquid behaves, and the reason for this is the property of surface tension. As I said earlier, why is it happening? Why surface tension comes into play? We'll be discussing later on in the next video. Right now I'm just trying to look at what are the effects of surface tension and how do we see surface tension in real life. So this is the first effect of surface tension, and the examples I have mentioned over here. Say for example, if I look at this surface and if I draw that surface over here, and on this surface if I place a needle very carefully, the needle will be able to sit on this surface. It is not floating over here, it just is able to sit over here, and that is because of surface tension. This is like a stretched membrane, and therefore this stretched membrane is able to withstand the weight of the needle acting in the downward direction, and therefore it doesn't sink. Actually, by law of flotation, because the density of the needle is greater than the density of water, obviously the needle should sink, but that doesn't happen because of surface tension, and of course because the weight of the needle is very, very small, and the surface tension force is able to withstand this. So that's one example of the stretched membrane effect of surface tension. The other example is of course insects walking on water. Because the weight is less, the surface tension is able to withstand this weight. So that's the first effect of surface tension. Let's look at one more effect of surface tension. The second effect of surface tension is with reference to drops of liquid. So what happens to drops of liquid? Let us say we have a glass plate. And let's say I form drops of mercury on this. What we observe is the drop of the mercury has a tendency to assume a spherical shape. That is because it tries to assume minimum surface area. For the same volume, sphere has the minimum area. So this drop of mercury which is getting formed, it tries to decrease its area, and in the process of decreasing its area, it assumes a spherical shape. The other example is end of a glass tube. Supposing we have a long glass tube, and so let us say we are heating it. When it melts over here, it will fall in the form of a drop, and the drop will have a spherical shape. Again, because the surface of this particular drop has surface tension, and therefore it has a tendency to assume minimum surface area because it wants to decrease its, or it wants to keep its potential energy minimum. Again, that is something which we'll be discussing in the video coming up. And this is another effect of surface tension that is observed, the tendency to assume minimum surface area and to form a spherical shape of drops. The third tendency of surface tension, or the effect of surface tension, is this to wet a surface. Here WET, wet is a verb, meaning that the tendency of some particular liquid to wet a surface. For example, if I take again a glass plate and I pour water on it, it will wet this surface. The surface of the entire surface of the glass plate will get wetted. WET, wetted. But if I put mercury on this, mercury will not wet it, and that is again because of surface tension of water and mercury. Of course, the real reason, or if we go into the microscopic quantities, it is because of what are known as cohesive forces and adhesive forces. And these forces and the intermolecular forces create surface tension, and that is why we see this effect of wetting of a surface or not wetting of a surface. And the other example of wetting of a surface is our use of detergents while washing clothes. All of us use detergents in washing clothes, and the objective over there is, by adding detergent, the surface tension of water decreases, and when surface tension of water decreases, the water is able to go into the fine holes of the clothes and clean it better, and that again is related to surface tension. The other application is we heat up water. We use warm water for washing clothes. When you heat up water, when the temperature goes up, again its surface tension goes down, and thereby it is able to clean the cloth better. Finally, capillarity. Capillary action is also because of surface tension. Capillary is a tube which has got a very, very small pore, and when we dip this inside a liquid, say for example water, what we observe is that the water starts rising up and goes to a particular height, and this is known as capillary action. This tube is known as a capillary, and this is capillary action, and again it is because of surface tension. And again there are two types of capillary actions which we will be discussing when we look at capillary action in detail. So in brief, these are some of the effects of surface tension, and these are some real life examples of surface tension. I will end the video by giving you some idea about the quantitative idea about surface tension. So if I again go back to this example, surface tension on the surface of the water, and if I look at this particular surface from the top, this is the top surface of the water, and if I assume, or if I imagine an imaginary line over here like this particular line experiences force in this particular direction, stretching effect in this direction, and there is, say, this force is F, and the length of the line is, say, L. And then surface tension T is given by force upon unit length. So this force is acting throughout the liquid, but the force per unit length will give me surface tension of this particular liquid. The unit will be Newton per meter. So this is the brief introduction to surface tension. I'll wind up the video by talking some of the factors on which surface tension depends. Surface tension of a liquid depends upon a number of factors. The first is nature of the liquid. Nature of the liquid. So some substances by nature have high surface tension value, whereas some have low surface tension value. So that is a natural characteristic of the surface tension. The second is temperature. As we discussed earlier over here, warm water surface tension is lesser. So generally when you heat up a liquid, its surface tension goes down. Third is when you add solvents, or let me say when you add impurities. Impurities probably is not the right word, but I'll use this word. When you add something to the liquid, for example, when you add detergent or soap, its surface tension decreases, and that's because this particular material is not completely soluble in water. But when you add a substance which is completely soluble, for example NaCl, common salt, the surface tension of water increases. So again it would depend upon whether it is soluble or insoluble. So these are some of the factors on which the value of surface tension of a particular liquid depends. So with this introduction to surface tension, we have created a background for understanding surface tension in more detail, and in the videos that will follow we will look at two things. One is a microscopic view of surface tension, what is exactly happening inside the liquid, what is happening to the molecules inside this particular liquid, and the reason why surface tension gets created. And secondly, we will also look at some quantitative aspect of surface tension. It is what is surface energy and what is the equation for surface energy and how do we arrive at that particular equation. These are some of the things that we will discuss in future videos with respect to surface tension. Thank you.